Good afternoon, everyone. So let us continue our discussion. Let us see the third week lecture. Let us revise, go through it, and then we'll discuss the problems. So this week, basically, we will be considering, we'll be studying basically on the repair and retrofitting of concrete structures. So initial classes, the earlier two classes, we basically studied the various types of damages that can occur in concrete structures and the various terminologies and various perspectives of a reinforced concrete structure. So today we'll be basically focusing on repair and retrofitting of concrete structures. So in this lecture, we will be covering considerations for repair and retrofitting, steps for repair and retrofitting, shoring and scaffolding, surface preparation, and repair materials. So if we see the plot here, so it shows the deterioration and performance over time. So the blue line represents the performance curve which deteriorates with time, and the red line basically refers the deterioration level which increases with time. And this is the service life of the structure. So if nothing is done, so it falls below the minimum your acceptance performance level before the service life. Okay, so that is the issue in the general structure. So it decreases the strength, decreases the durability, and increases the rate of deterioration. However, if we see the repair, if we start repairing, okay, so we will see that the level of the maximum acceptance deterioration level, so that is not reached if repairing is done. Okay, so that means it is reached after the service life, not before that. So that is the benefit of repairing. Okay, so it increases the durability, does not increase the strength, slows down the rate of deterioration. Similarly, if we go for retrofitting, okay, so retrofitting will decrease the performance and decrease the rate of decrease in the performance curve. Okay, so that means that it will basically the service life will basically be increased. Okay, from here it will reach here. Okay, so it increases the strength, increases the durability, and increases the level of performance. So if we see here, so basically the framework for repairing and retrofitting, so this is basically, so in existing infrastructure, first initial inspection is done through visual, okay, through eyes. Then that is just a brief inspection. Then we go for periodic inspection, which is a regular visual inspection. And then finally we go for detailed investigation, which is NDT, non-destructive testing and coring. And after getting the results, we actually ask the question of evaluation. So what should be the basis of evaluation? Will it be repairing or will it be retrofitting? That is enhancing the performance level or enhancing the or reducing the deterioration level. Okay, so that is based on analysis of test results. Okay, so that is the framework for repairing and retrofitting. So this repairing and retrofitting done in terms of functionality, that is the functional performance, structural safety, which is the load carrying capacity, flexure, shear, axial torsion, fatigue resistance, ductility, etc. The serviceability, which is deflection, level difference, vibration, noise. Then appearance, which is the aesthetics, surface characteristics, crack width, crack density, etc. The durability, which is the long-term performance. The important stages for repair and retrofitting, okay, so they are basically to determine the cause or causes of damage, to evaluate the extent of damage, to evaluate the need for repair and retrofitting, to select the repair retrofitting method and the corresponding material or materials, to prepare the existing structure suitable for repair or retrofitting, to implement the repair retrofitting method, to cure and finish the process for usage, and to evaluate the structure after retrofitting. So these are some of the important stages for repair and retrofitting. And what are the challenges for repair and retrofit of existing structure? So they are a realistic assessment of the present condition of the structure, extent of repair retrofitting to be done, selection of proper repair retrofitting method and material, deterioration after repair retrofit, access to the structural component to be repaired retrofitted as the structure is still in use, skill, manpower, and cost. So these are the challenges basically. Now, the steps for repair and retrofitting. So, firstly, fixing suitable support and formwork. So, this is necessary for application of the selected repair and retrofitting method. Then, the surface preparation. So, that is basically sandblasting, removal of dust and debris by air blasting, water blasting, brooming, etc. Cleaning and primering or coating of corroded steel reinforcements, and application of appropriate measure. That is applying the suitable repair and retrofitting method using the selected materials. So these are some of the ways. Okay, So in this way, in this in this regard, let us go through some of the basic ways of repairing and retrofitting. Okay. So initially, let us study shoring. So this is means of providing support temporarily to get stability of a structure under certain circumstances during construction, repair, or alteration. Okay, so that is basically providing temporary support. Okay, during repairing basically. Okay, so that is shoring, and it is adopted when stability of a structure is endangered due to unequal settlement during construction or during any period of its service life, removal of a defective portion of the structure, remodeling of walls, changing positions of windows, etc., alterations in adjacent buildings. So these are some of the times when it is adopted. So this shoring, it is basically made of timber and steel tubes. So the timber is to be basically surface coated, and it is designed based on the load it has to sustain and duration of load. It may be internal or external, sometimes on both sides of the journal of the wall, sorry, for additional stability, and no time limit for shoring, so it may be kept for long as necessary. Okay, so these are some of the characteristics. Then uh, the types of shoring, so there are basically three types: raking or inclined shores, so angle of shores 60 degree to 75 degree for external supports. Then flying or horizontal shores, so they are restrained against tilting, overturning. Dead or vertical shores, so basically provided on ground supporting vertical loads. So these are the types of shoring. So this is the single raking or inclined timber shore. These are the two structures supported with a single flying or horizontal timber shore, and this is dead or vertical shoring. Okay, so these are the three supports shores basically. So these are some of the live examples. This is vertical hydraulic vertical shoring. This is vertical shoring. This is inclined and horizontal shoring. Okay, so these are the live examples. So next we go for scaffolding. So scaffolding, as we know, it is to provide access areas for repair, retrofitting, constructing structures at longer heights. Temporary structure on the outside of a structure made of wooden planks and metal poles used by workmen for repairing, construction, retrofitting, painting, etc. So these are some of the examples of scaffolding for repair and retrofitting, as you can see here. Uh, so apart from that, there is one more important perspective which needs to be learned, so that is the surface preparation. So surface repair involves the process of conditioning the existing structure to receive repair materials. So conditioning is required to remove deteriorated, contaminated, or damaged concrete to provide surfaces that will promote bonding of the repair materials. The surface preparation process is one of the most critical phases of retrofitting work. So this is an example of surface preparation. So basically, the general surface preparation procedure is basically a five-step process. Okay, so first step is locate area to be repaired. Hammer, sounding, or chain drag are generally used when locating delamination. That is the separation of the surface layers. Okay, so as we studied last class, so that is we have to basically locate the area to be repaired. Second step is removing deteriorated concrete using acceptable methods. Surfaces of existing concrete expected to receive the repair material must be sound, clean, and free of bond inhibiting materials. The third step basically is to prepare surface repair boundaries to prevent to prevent feeder aged conditions. So that is, it should not, the repairing should not damage the actual the sound areas. Okay, the proper healthy areas, it should not deteriorate. So we should we should basically give some repair boundaries. Okay, and then it is done by saw cutting and the perimeter to recess the edge. Okay, the fourth step will be to clean the surface of any exposed reinforcing steel in the existing concrete. It is critical to achieve an adequate bond between the repair and the existing concrete. And the fifth step is SSD, that is saturated surface dry or damp concrete is ideal prior to placing repair material. Okay, so that is these are the five steps that needs to be done for surface preparation. And thereafter, basically, the concrete for actually for doing this, we basically use the various types of equipments. Okay, so for partial depth concrete removal methods, so some of the methods used are basically pneumatic chipping hammer. So pneumatic is basically when the force is applied using some gas, or basically pressure is applied using gas or some fluid. Okay, so that is pneumatic. Okay, uh, so basically this is a pneumatic chipping hammer. So chipping action due to round chisel that rotates freely. The hydro removal is removal of the surface due to water pressure. Okay, so this is basically water hydro removal, and this is basically due to gas. Okay, so that is the basically difference, air or gas. Then there is a rotary milling machine. Okay, so this is milling of top pavement surface. It is done like this. Then there is pneumatic scabbler. So this is handheld device used to remove the top surface. Again, pneumatic means using air or gas. Then that those are the ways for partial depth. Okay, and for full depth we use hydro demolition. So that is selective demolition method that involves removing damaged or low strength concrete while keeping intact the healthy concrete. And it is full depth concrete removal using high pressure water. Then there is handheld pneumatic breaker. Okay, so this is full depth concrete removal using repeated vertical movement of hammer. Okay, so these are the techniques. Then there is splitters. Okay, so this is the example. So hydraulic splitting means controlled demolition. Hydraulic splitting eliminates both shocks and vibrations associated with large impact tools. Then there are pneumatic or hydraulic mounted breakers. Okay, so hydraulic means using water, pneumatic is using air or gas. So they are used in road and bridge demolition, indoor foundation breaking, light rock breaking, etc. So the desirable properties of repair materials are low shrinkage, quick setting or hardening properties, good bond strength with existing substrate, sufficient strength and compatible mechanical properties, adequate workability, minimal curing requirement, should allow relative movement, air and water impermeability, non-hazardous and non-polluting, and durable and cost effective. So these are some of the desirable properties. And the repair materials are cement mortar, polymer modified mortars, epoxy resins, low viscosity epoxy sealing compounds, epoxy mortar, sealers and coatings, polyurethane and meth acrylate resins, silane and siloxane sealing compounds, and chemical compounds. Okay, so these are some of the repair materials. So let us study a bit more detail. Okay, so this is the cement mortar. So this is mortar is basically mixture of cement and sand, and it may also contain the supplementary cementitious materials, that those are SCMs, and chemical admixtures. So they basically constitute the binder, and they should be consumed within 30 minutes after adding water, because generally this is the minimum duration of the setting time, initial setting time, if you remember. So that is about cement mortar. Then there is polymer modified cement mortar. So this is the polymer modified one, and this is the unmodified. Okay, so normal one. Okay, so mixture of mortar and polymer or latex in dispersed form. Okay, and your this one, polymer latexes consisting of a very small diameter particles based on elastomeric and thermoplastic materials emulsified in water. Okay, so these are some of the basically characteristics. Okay, then there are epoxy resins. Okay, so mixture of epoxy resin hardener in specified proportion. Epoxy resin generally created by transforming liquid polyethers into infusible solids through a special curing process. It results of a chemical reaction between epichlorohydrin and bisphenol A. Hardener, they are aliphatic and aromatic amines and polyamides. So this is epoxy resin. Then there is low viscosity epoxy sealing compounds. So there are additional diluents. Their additional diluents are added for lowering the viscosity. Coal tar epoxy system, rubber modified epoxy system. So then there is epoxy mortar. So mixture of epoxy and sand, or epoxy sand and coarse aggregates in specified proportions. Then there is sealers and coatings. So numerous compositions with meth acrylate based formulations, polysiloxane based resin formulations, etc. Then there is repair materials such as silanes and siloxanes, the two most common types of water repellents. So both derive from silicone molecules. Silicone is a generic name for a wide variety of polymeric chains constructed around the molecular structure of SiO. Okay, so this is an example of silane and siloxane sealing compound. So in this lecture, we have basically studied the considerations for repair and retrofitting, the steps for repair and retrofitting, the shoring and scaffolding, surface preparation, and repair materials. So next lecture basically will be on the repair techniques. So it will cover the surface preparation near corroded reinforcements and the repair of cracks by sealing and grouting methods. So the surface preparation near corroded reinforcement. So for concrete surface preparation, so this is basically done the concrete surface preparation when corroded reinforcement is encountered, as seen in this example. So as you can see, this is the corroded reinforcement, and here surface after removal. So here basically we remove the surface of loose concrete. Okay, so this is the surface basically after removal of loose concrete. So this is basically the pristine one. Okay, the native, the actual one. Okay, so then your this one the how to do the surface preparation basically. uh, the perimeter of repair area is cut by saw or other methods approximately a 90-degree angle to the surface. So as can be seen here, so this is the surface of steel, okay, which is cleaned. This is the concrete removed under corroded bar, and the concrete removed to expose corroded bars basically. Okay, so we have done this. So this was the pristine one, actual one, okay, undamaged one, original, and here we have cut it properly at 90-degree angles to expose it properly. Okay, so then we have to go for cleaning of reinforcing steel. So first, concrete is to be removed around full circumference of the bar. Okay, so we have to remove it full circumference of the bar. Then heavy oxides and other bond inhibiting materials removed by needle scalers, high pressure water cleaning, abrasive blast cleaning, power wire brushing, etc. So this is done, okay, to remove heavy oxides and other bond inhibiting materials. Okay, then bars damaged during removal operations are required to be repaired or replaced, because during this process some bars may be damaged, so we need to repair or replace them also. Then special coatings by alkaline slurry coating, cathodic protection, epoxy coating may be applied to add additional protection to the reinforcing bars. So this can be done then, the special coatings. So how the cleaning of reinforcing steel is done? So we use needle scalers. Okay, so basically, so needle scalers are again pneumatic tools using uses air or gas. So utilizing small diameter steel rods powered by an internal piston, the steel rods basically hit the intended surface, causing removal of surface materials. So then there is high pressure water cleaning. So here water mixed with sand cleans concrete and steel surfaces, removing unsound materials. That results in a roughened surface, promoting a better bond with coating or repair materials. So that is again a way. Then there is abrasive blast cleaning. Okay, so abrasive, so basically abrasive means it creates roughness due to interaction of the this jet. Okay, so abrasives mixed with pressurized air and projected through a nozzle to clean steel or concrete surface. Then there is power wire brushing. So power brush finishing employs wire, elastomer bonded wire, or non-metallic cord, natural fiber, or synthetic brushing wheels in automatic machines, semi-automatic machines, and portable air tools to smooth or roughen surfaces, remove surface oxidation, and weld scale. Okay, then there is so after using this, so we can clean basically the steel surface. Now the reinforcing steel repair, okay, from section loss, how it is to be conducted. Okay, let us see that. So this is basically the loss of section and the affected length. Okay, so if the reinforcing steel has lost more than 25% of its cross section, or 20% if two or more adjacent bars are affected in gross, okay, then reinforcing steel repair is generally required. 25%, that is 25% of one cross section, or 20% of the total gross section if two or more bars are present. Okay, if that happens, then reinforcing steel repair is generally required. So this is the affected length basically. If this is the case, then we have to provide a supplemental bar over that. Okay, and it should have an extension of this much, which is called the required lap in both the sides. Okay, so supplemental bar over affected length. New bar should be mechanically spliced. So this is basically called splicing, if you remember. So new bar should be mechanically spliced to affected bar or placed parallel to existing bar. So it is complete bar replacement. So one thing to note here is when damage to reinforcing steel is uncovered, it is good practice to perform a structural review of situation. So proper retrofitting can be done. Okay. So now concrete removal geometry for repair. So these are some of the cases. Okay. So one is beam or rib. Okay. So this is section, and basically this is the elevation. Okay. So these are some of the repairment that is necessary in beam or rib. Then there is basically this one, your if there is partial depth and full depth, okay, in slab or wall. Okay, so this can be again a case. Then there is column corners. Okay, so if you see here, so this is the elevation, and these are the cases basically. So these are some of the cases basically which need proper uh, understanding and for a proper way of learning how to retrofit the area. Okay, so bonding repair, basically material bonding repair materials to existing concrete. So considerations for development of adequate bond, so they can be clean and sound substrate. Okay, rough and profile of substrate for mechanical interlocking actions. Okay, and open pore structure in substrate, repair material bonding agent with sufficient pace for absorption into substrate pores, application of repair material with sufficient pressure to facilitate contact between the two surfaces. So these are some of the general ways of repairing. Okay, so this is an example basically the bond characteristics between new and existing concrete. If you see how it is to be done, it has been shown, taken from a book basically. So, what is basically concrete repair? Okay, so basically it consists of these 6 steps. One is repair of cracks, repair of patches, repair of leakages, replacement of structurally weak concrete, replacement of spalling or delaminated concrete, and replacement of carbonated concrete surrounding reinforcement. Okay, so these are some of the repairing ways in of concrete. Okay, so the repair techniques can be sealing, surface coating, dry packing, grouting, gravity filling, surface impregnation, drilling and plugging, pre-place aggregate concrete, routing and sealing, stitching and stapling, shotcrete, and ferro cement. So these are the ways basically. So let us go one by one. So this is repair of cracks in concrete by sealing. Okay, so this is impregnation of sealants, so entry of sealants, intrusion of sealants into the cracks, and surface coating. Okay, so these are some of the this is basically sealing. Okay, so this is the surface coating, and this is impregnation of epoxy into the crack basically. Okay, so basically the depth of crack less than cover thickness. Okay, so that is basically sealing. Now let us go to surface coating. So this is done when the depth of crack is less than the cover thickness. Okay, so this is basically the cover. Okay, so if the depth of crack is less, then we go for surface coating. And replacement of the damaged concrete with cement mortar, surface coating only and no sealants into the cracks. Okay, so this is the surface coating, this is crack without resin, and this is the steel, this is the cement mortar. Okay, so the repair so this is basically near by surface coating. Then there is repair of cracked concrete near corroded reinforcement. So there removal of portions contaminated with chloride or carbonation, replacement of the section with cement mortar. So this is the cement mortar, this is the corrosion in steel, and this is the steel basically. So here we basically go for how like we basically see how to do it. Okay, so there, removal of portions contaminated with chloride carbonation, application of corrosion inhibitor to, so here basically we provide corrosion inhibitor in reinforcement, and the replacement of the section with polymer cement mortar and surface coating. So this is the additional part we have to do. First we have to provide corrosion inhibitor here, and then we have to provide polymer cement mortar, and then go for surface coating. Okay, so this is the way. Okay, and we have to impregnate also that area. Okay, then there is repair of damaged concrete near corroded reinforcement. So the replacement of damaged concrete with polymer modified cement mortar can also be done. Okay, so we basically add polymer modified cement mortar. Okay, so if we replace the entire area, okay, around the repair, so that is basically considered a good replacement. However, if we consider only the crack area but we don't go below, so that is a bad replacement basically. So ideal is to cover the entire area from the cracks till 360 degree of the rebar. Okay, then there is dry pack and epoxy bonded dry pack. So this is dry pack for crack sealing. So dry cement sand mortar, 1 is to 2.5 with little water to form a ball. So immediately it is immediately packed and placed in thin layers of 8 to 10 and compacted with a hammer. So epoxy can also be used as binder. Okay, so epoxy bonded dry pack, and they are suitable for small areas basically. So that is a way. So here it is the application of dry pack at the bottom surface of a deck slab. So it is shown here basically. Then let us come to a common term. Okay, so it is both used in concrete as well as in soil improvement. So that is basically grouting. Okay, it is a famous term. So that is basically process of inserting a material at a high pressure into cavities, voids, joints, cracks, etc. in concrete or masonry to restore its monolithic nature, filling voids, stopping leakages, restoring strength, etc. Grout is a mixture of cement, water reducing admixtures, expansion agents, pozzolanas, and chemicals, etc. So that is basically the process of insertion of a material at high pressure is grouting, okay, into the voids, cavities. So the procedure for grouting is drilling of grouting holes using jackhammer and shot drill, arrangement of grout pipes that are pipes with 4.5 centimeter diameter, 45 to 90 centimeter long. Then there is cleaning of cracks by injecting water at high pressure into cracks. Then there is inserting the grout into the holes. So that is done at a high pressure of about 0.65 kg per centimeter square, and then adequate curing after grouting. Okay, so these are the ways of performing grouting. So this is the practical natural example of how it is done experimentally. So grouting on concrete surface, as you can see here. The techniques for grouting can be three types. So one is your cement grout. Okay, one is cement grouting, one is epoxy injection grouting, and one is chemical grouting. So these are the basically three types of grouting. Okay, so the cement grouting basically, so it is a composite material generally consisting of water, cement, and sand. So basically, it is a cement mortar. Okay, so the cement grouting or slurry grouting. So it is used to fill underground voids, underpin foundations to strengthen granular soils and materials. Okay, so this underpin we will be basically studying after some time. So underground voids you understand. So these are the grout pipes basically. So this is the example, experimental example of placement of grout pipes for grouting, and this is the cement slurry, basically the cement mortar. Okay, so the cement grouting application, so these are it is used when the cracks are dormant, when cracks are active but cause of cracking has been determined and remedial action has been taken, when honeycombing is present in concrete structures, when masonry is hollow, and when deep leached mortar joints are present. So these are the times when the cement grouting application is done. Then comes the epoxy injection grouting. So epoxy resin and a low viscosity liquid hardener is injected into the cracks with pressure to fill up the voids and cracks. So it is useful for repair of small crack as narrow as 0.05 So the steps for epoxy grouting are cleaning of the cracks, sealing the crack surface using small channels or ports into the seal, and then there is injecting epoxy through the channels to fill up the cracks, and then finally removing the surface seal after curing of the epoxy. So these are basically the ways, and this is an experimental example of epoxy injection through small channel. So epoxy injection grouting, if you see, these are the live examples. So it is these are the corroded and damaged areas, and this is the epoxy grouting. Okay, channels fixing for epoxy grouting. Then so application wise, so epoxy grout is a waterproof and almost completely resistant to stains. It does not crack, shrink, or discolor, making it ideal for applying in wet areas. It is highly resistant to the harsh chemicals, does not need to be sealed due to its non-porous nature. So these are some of its benefits. Then let us come to the chemical grout. Okay, so chemical grout is pure solution with no particles in suspension. Example, hydrophilic, that is water loving, polyurethane grouting material. Solution grouts commonly used as acrylamides, polyurethanes, acrylates, epoxies, and sodium silicates. The major purpose to keep the soil in place by stabilization, eliminating differential settlement of structures over it. Also for the purpose of controlling water leakage. So this is a stabilization of sand to prevent foundation movement. Okay, so this is the sketch example. Okay, and this is the practical example. Okay, so how it is done: strengthening of sand to increase bearing capacity, stabilization and strengthening of sand using chemical grouting. Now the gravity filling of cracks. Okay, so this is basically sealing of cracks of width 0.03 to 2.0 mm by gravity filling using low viscosity monomers and resins. The cleaning of crack surface by air or water blasting and allowed to dry for several days. Then resin is poured onto the surface and sprayed with brooms, rollers, or squeegees. Okay, which slowly recedes into the cracks. So if you remember, squeegees basically that mopping and then squeezing. Okay, so that type of instrument it uses. Okay, so it first mops and then it squeezes. Okay, so that is squeegees, and then excess material to be broomed off. Okay, so it should be removed. Then let us see the surface impregnation using vacuum method. So that basically creates partial vacuum by a vacuum source within the concrete, and excess water is sucked out, and then introducing the repair material like resin of very low viscosity. The resin, which can be of methyl acrylate, expanding vinyl ester gel, etc., enters into cracks, micro cracks width of up to 5 microns, voids capillary system. The complete filling up of cracks and voids is done. Upon curing, results into strong and sound concrete and improved bonding due to lack of air voids. Okay, so this is using the vacuum method for surface impregnation. So the equipment basically uses vacuum pump, water extractor, filtering pad, screed, board vibrator, and dewatering through vacuum results into good workability and high strength, low permeability, smooth surface with reduced shrinkage, reduced corrosion type of distresses as moisture is evacuated. So these are the some of the characteristics. So this basically is the live example of surface impregnation using vacuum method. So here the heavily used A40 motorway in London was repaired on a January night. Polyethylene film was laid and sealed, and operators were connecting the vacuum lines to evacuate and dry the concrete before applying the resin basically. Okay, so that was using the vacuum method. So if we summarize this lecture, we basically understood a variety of repair techniques. They were surface preparation near corroded reinforcements and repair of cracks by sealing and grouting methods basically. Now the next lecture will basically continuing the repair. We'll be continuing the repair techniques basically. So there are basically three types of techniques we'll be discussing in this lecture. One is we'll be continuing repair of cracks by various grouting methods. We'll be studying shotcrete and we'll be studying ferro cement. So the drilling and plugging of cracks basically, so they're applicable when cracks run approximately in straight lines and are accessible from one end. They're often used to prevent vertical cracks in retaining walls. The drilling down the length of the crack and grouting it is done to form a key. A hole is drilled diameter which has a diameter of 50 to 75 mm, cleaned and filled with grout. Grout key prevents the transverse movements of the sections of concrete adjacent to crack and reduces loss of material or leakage. So these are some of the ways of doing it. So this is an example basically. So repair of retaining wall by drilling and plugging. So this is the key with precast concrete or mortar. It is attached above. So a hole drill in stem of wall following down the crack. Okay, and basically this is the wall basically, and this is the crack. Okay, so it is basically so this repairing is done by the drilling and plugging phenomenon. Okay, concept. So then we come to the pre-placed aggregate concrete. So it is useful when conventional concrete is difficult. Example areas of heavy reinforcements under water concreting. So it is clean graded coarse aggregates densely pre-packed into the formwork. Grout is forced through pipes or tubes into the voids of pre-packed aggregates. Grout, which is a mixture of cement, sand, pozzolana, or and superplasticizer. Coarse aggregates need to be washed and screened before placing to remove all fines and deleterious materials. And the grouting starts from the bottom of pre-packed aggregates. Okay, so that these are some of the characteristics of pre-placed aggregate. So that is mainly used pre-placed aggregate concrete when conventional concreting is difficult. For example, heavy reinforcement areas. Okay. So this is basically an example. This is sketch how it is done, and grouting through pre-placed coarse aggregates of the retaining wall for the retaining wall case basically. So then this is an example grouting through, again this is a live example, okay, of the pre-placed coarse aggregates of this structure. and this is the flowable grout mixed and pumped into formed cavity, filling space between aggregate. Okay, so this is the sketch example. Then we shall go through routing and sealing of cracks. Okay, so this is repair by enlarging the crack along its exposed face, filling and sealing the crack with suitable joint sealant. Sealant can be epoxies, urethanes, silicones, polysulfides, asphaltic materials, polymer mortars, etc. They are applicable for horizontal, vertical, or curved surfaces having narrow to wide cracks. They are simple technique and cost effective. Okay, and the routing and sealing of cracks on a road surface. This is the example basically. So, and how it is done first? First routing is done. Okay, so routing is basically making the crack basically wider. Okay, so at the crack a groove is made which is up from 6 to 25 mm. Okay, big, using a concrete saw cutter or right angle grinder. Okay, so we basically increase the width. Okay, up to 25 mm, and then cleaning of the groove by air blasting, sand blasting, water blasting, and then dried. Then the sealant is placed, okay, into the dry groove and allowed to cure. That is the sealing. Okay, a bond breaker may be provided at the bottom of the groove to allow the sealant to change shape without causing stress concentration. The bond breaker is basically made of polyethylene strip or tape. Okay, so this is crack sealed road surface example. So it is the sketch which shows how it is done. So repair of crack by sealing. So first is this is the original crack which was very small. Then routing was done. Okay, so we made it minimum of 1 by 4 inches. Okay, so 0.25 inches minimum. It was groove cut was done using saw or chipping tools. And finally sealing was done. Okay, it's joint seal as you can see here. And the effect of bond breaking, if you can see here, so it is crock closed. Okay, so here there is no bond breaker and there with bond breaker. So everywhere it is different. Okay. Then next example of repairing of cracks is stitching and stapling. Okay, so stitching is basically holes are drilled in concrete on both sides of the crack, insertion of steel bars into the hole from one end to another end, filling up the hole by suitable grout material or epoxy resin. So this is basically stitching. And what is stapling? It here the groove is cut on concrete surface perpendicular to the crack, insertion of steel bars from the top, and filling up the groove by suitable grout material or epoxy resin. Okay, so that is basically stitching and stapling. So this is the example of stitching. Basically we are inserting the rods inside, okay, and it should cross the crack. Basically from one side it should cross to the other side from both, and that should be done from both the sides. So one is inserted from this side and one is inserted from that side, with some space in between. Okay, so that they can overpass each other. Okay, so this is stitching. Okay, and this is the stapling. Okay, so we are making grooves. Okay, so this was the crack, then we made some grooves. Okay, and there we inserted the rods, and then we basically applied the mortar. Okay, we basically so we basically fill the groove with suitable grout material or epoxy resin. Okay, so mortar and all, we fill the groove. Okay, after placing the steel bars or the rods. Okay, so this is the example of staples used. Okay, so this is basically the stapling. Okay, this is the stapling that is used, and maybe these are the this one the stitches. Okay, this is the stitches, and this is again the staple. Okay, so that is the way it is done, stitching and stapling on cracked concrete roads. Then there is thin polymer overlay. They are used to improve the abrasion resistance of hardened surface, used to improve waterproofing and protective surface. Polymer overlay applied in less than 10 millimeter thickness. Polymer overlay comprises of primer coat and sealant. Primer coat is basically made of vinyl ester resin, and sealant is vinyl ester resin plus silica filler or titanium dioxide pigment or black carbon black pigment, etc. So this is polymer overlay on a road surface. Okay, so that is shown here. Then there is thin epoxy overlay. So they are used to improve the abrasion resistance of concrete surface. They are used to improve waterproofing and protective surface. Epoxy overlay 2 to 3 mm thickness, resin plus hardener, and faster strength gain it gives. Epoxy overlay sometimes require protective coating also. Okay, so this is the epoxy overlay. So cracks, broad cast aggregate, epoxy resin, and here it is the base concrete. So this is the covering, it is done basically the repairing and retrofitting done. Okay, epoxy overlay. Then there is protective seal coat on entire surface. So the protective layer used as seal coat on hardened surface. So this protection can be from ingress of water and harmful chemicals, the adhesions of surface, compatibility with alkaline atmosphere, capacity to cover surface irregularities with ease of application, It may contain some pigments to improve aesthetics. The seal coat of polyurethane, epoxy, alkyds, chlorinated rubber, acrylic emulsions, etc. So this is the protective seal coat on entire surface being shown experimentally. Then there is shotcrete. Okay, so it is also called unite or pneumatically applied concrete or mortar. So the deposition of materials in layers over the surface under pressure without supporting formwork. It is useful for restoring small surfaces, and they are dry mix process, or it has dry mix process or wet mix process. Okay, so here basically we are basically apply, it is type of grouting only, where we basically are applying concrete or mortar pneumatically using air or gas. Okay, so almost all the techniques are somewhat related. Okay, very minor differences. Okay, so there are two types, dry mix and wet mix process. Let us see here. So the dry mix process basically thoroughly mixing the dry materials, feeding of the materials in a mechanical feeder or gun, carrying the material by compressed air through a hose to a special nozzle, introducing water at nozzle point and intimately mixing with other ingredients at the nozzle, jetting the mixture from the nozzle at high velocity onto the surface to receive the shotcrete. So basically, the dry mix processes, everything is mixed dry, and only water is introduced only at the nozzle point, at the end point. Okay, so that is the dry mix process. So this is the example basically. So it is water is mixed and only at the end point of the nozzle. Okay, so this is a schematic diagram of dry mix process, and this is a practical life example of dry mix shotcrete applied on a curved surface. Okay. Next, we come to the wet mix process. So this is thoroughly mixing all the ingredients, including water. So this is like the normal process. Okay, we together we mix all the process, all the ingredients, including water. Okay, and feeding the mixture into the delivery equipment, delivering the mixture by compressed air up to the nozzle, and jetting the mixture from the nozzle at high velocity onto the surface to receive the shotcrete. Okay, so this is the wet mix process. So this is the example of how it has been done. Okay, so schematic diagram of the wet mix process, and then this is the practical live example. Okay, wet mix shotcrete applied on a surface. So what is the advantages of shotcreting? Okay, so shotcreting undergoes placement and compaction simultaneously. It is dense, homogeneous, high strength, and waterproof. It can be applied on any type and any shape of surfaces like vertical, horizontal, curved, etc. The fibers can be added as an ingredient for shotcrete. Okay, so these are the advantages of shotcreting. Then let us come to ferrocement. So they are thin wall concrete thickness ranging between 12 to 30 for crack or surface repair. Okay, so their thickness is 12 to 30 or to 1.2 to 3 centimeters. A very thin wall concrete. The hydraulic cement mortar reinforced with a minimum 2 layers of continuous and orthogonally woven wire mesh 4 to 6 apart, and the cement mortar is admixed with plasticizers and polymers to seal the cracks. Wire mesh is mechanically connected with the concrete surface by nails fixed with suitable epoxy bonding system. The protective layer against water and environment is also present. Okay, so these are the examples of ferrocement application. So ferro is basically, it contains this one, the wire. Okay, wire mesh. So that is basically made up of iron. Okay, steel iron. So that's why it is called ferrocement. Okay, so it is basically hand plastering semi mechanized with and uniting. Okay, uniting it uses pneumatic. Okay, pneumatic force. Pneumatic is basically, if you remember, so it is this one, using air or your gas. Okay, so that is unite. So basically, if we talk here, the normally Portland cement and fine aggregates which are greater than 2.36 are used in ferrocement in the ratio of 1 is to 2 or 1 is to 3, and basically with water cement ratio of 0.40 to 0.45 it is basically used. And basically, so it is almost like the normal concrete only, but we don't use the coarse aggregate. Okay, so here the plasticizer and admixtures and flashes are also used, and a reinforcement, it is a skeleton steel as I told you, or wire mesh made of iron, and special technique for compacting ferrocement layers using orbital vibrators to ensure proper encapsulation of wire mesh in cement mortar. Okay, so proper vibrators are used so that it is encapsulated, not exposed outside. Okay, and it is like there is proper cover of the mortar cement, okay, and then it is water cured, okay. So the skeleton steel, so for that steel bar of about 8 mm diameter spaced at 75 to 100 mm center to center, and they are tied reinforcement or welded wire fabric. So the wire mesh, so galvanized wire of 0.5 to 1.5 mm diameter and spaced at 6 to 20 mm center to center. So it is formed by welding, weaving, twisting the wires. So this is the application of ferro cement, okay. So what are the this one characteristics of ferrocement? So firstly, they are versatile. That is they can be formed in any shape. Secondly, flexibility in cutting, drilling, jointing. Thirdly, it is fire resistant, impermeable, low cost. Fourthly, it is low durable. It has low durability. So that is a negative. Okay. Fifthly, it is low strength. Again, negative. Sixth is chances of corrosion of wire mesh. It is a problem. And last is labor intensive. So three are good. This one good points and four are bad points. Okay. So if we summarize this lecture, we can say that we studied about the repair techniques basically, and there we basically tried to understand the repair of cracks by various grouting methods, drilling and plugging, pre-placed aggregate concrete, routing and sealing, stitching and stapling, thin epoxy overlay, thin polymer overlay, and we also studied shotcreting and ferrocement. Okay. So next lecture we will be again continuing the repair techniques. This time we will be basically studying the corrosion treatment of steel reinforcements. Okay. So if we go here, we will see that chemical and electrochemical methods for treatment of corrosion in steel reinforcement. So there is cathodic protection, chloride extraction, realkalization, corrosion inhibiting admixtures, and reinforcement coatings. So these are some of the methods of chemical and electrochemical methods for treatment of corrosion in steel in reinforcement. So as we studied in the first class itself, so if you remember, there's corrosion based, a simple corrosion phenomena. So in anode basically, this oxidation occurs where iron gets released. Basically, it oxidizes and releases two electrons, and these electrons go to the cathode. Okay, and along with water and oxygen, it becomes hydroxide. So this hydroxide reacts with this Fe++, and it becomes ferrous hydroxide, which is basically rust. Okay, so that is the corrosion process. If you remember, we discussed this properly in first class. So the corrosion occurs because of electrochemical reaction. So this is the actual corrosion. Okay, actual corrosion is an electrochemical process. However, in the lab for research purpose, we also do corrosion which is much faster, and it uses current. Okay, so that is electrolytic corrosion. Okay, that is electrolytic reaction, and here it is electrochemical reaction. So the corrosion occurs because of electrochemical reaction between two dissimilar elements in electrical contact in presence of oxygen and moisture. Due to the difference in electrochemical potential, anodic and cathodic reactions take place. Flow of corrosion current from anodic to cathodic regions of the steel reinforcement. So that is basically the phenomenon. Okay. So the principles of cathodic protection, based on the nature of flow of corrosion current, a direct current is applied in opposition to the corrosion current. Okay, so the cathodic protection involves placing the reinforcement in a concrete structure within a circuit in such a manner that the steel becomes polarized and acts as the cathode. Okay, and as a result, it does not undergo corrosion at a significant rate. So basically, always corrosion occurs near the anode, okay, not the cathode. Cathode only produces the hydroxide, but the oxidation of iron occurs at the anode. Okay, so if we can make the basically if we can make the steel cathode, okay, so it does not undergo corrosion at a significant rate. Okay, so the two approaches of cathodic protection are, one, I impress current technique, okay, and the second is galvanic cathodic protection. Okay, so this technique here we are using as a savior, okay, how to make it a cathode. Okay, but this same technique can also be used for fast corrosion. Okay, if we make that steel rebar as the anode. Okay, so that is dependent on how the rebar is behaving. Is it an anode or cathode? If it is acting as a cathode, it is a cathodic protection. If it is acting as an anode, it is resulting in faster corrosion. Okay, so let us see it properly. Increased current cathodic protection. So it involves connecting the steel reinforcement, which requires treatment, to a metal or carbon component and applying a direct current between the reinforcement and the component. The reinforcement becomes the cathode in an electrochemical cell, and the other conductive material like titanium, certain zinc or aluminum alloys, conductive titanium based ceramics and carbon becomes the anode. Okay, since it is the anode that will undergo corrosion, the steel being the cathode remains intact. Okay, so that is basically the thing done. Okay, so direct current is applied and the reinforcement becomes the cathode. Okay, so because anode is generally undergo corrosion, the steel remains intact. So this is the working principle of impulse current cathodic protection. If you can see here, okay. So if you can see here, so it becomes the cathode, okay, and it becomes so the anode, okay, here. So current is applied like this. So that's why it is this area is like it is either it is the corrosion reduces or it is prevented. Okay? So the anode is made from a conductive material that is inert and does not vulnerable to corrosion. The circuit is completed by the diffusion of ions through the concrete pore solution, with anions such as hydroxide and chloride ions, if present, migrating from the cathode to the anode, and cations. Okay, so they so that is basically always true. Okay, cathode, the hydroxide chloride ions, they always migrate from cathode to the anode. Okay, in the corrosion process itself. Okay, and cations including calcium, sodium and potassium ions removing towards the cathode. Okay, so that is the opposite. In the corrosion process, instead of this, the electrons move, okay, from the cathode to the, so from the anode to the cathode. Okay, in corrosion. And in cathodic protection, here these are moving. Okay, the these elements, basically the alkaline elements. Okay, so passivation of steel gets strengthened due to the buildup of alkalinity at the cathode, and production of OH ions, minus ions. So more is the this is produced, more this is also coming. Okay? So that's why, and because this is not the member, this is not the structure member. Okay, so it does not result into corrosion, and it is inert, basically, as we studied in the last slide also. So it is basically inert, and that is the way how it is this is inert, and it is not vulnerable to corrosion. So even if the hydroxide goes, okay, so there is no Fe plus plus. Okay, so it will not form FeOH2, which is corrosion. Okay, so it is inert. And because this sodium, potassium, calcium, the material is made of sodium, potassium, calcium. So basically, as you can see here, so they are made from various other conductive material, and the so this anode, basically, so it releases all types of the alkaline elements. Okay, sodium, potassium, calcium, and because of that, it does not develop passivity. Okay, so the passivity is increased, basically, sorry, and that's why there is no chance of corrosion. Okay, so basically we have removed we have changed the electrodes. In corrosion, the anode is there as the rebar. In here, the cathode is there as the rebar. Okay, so then let us study the other method. Okay, so this method is basically the galvanic cathodic protection. Okay, so the galvanic corrosion, so it is an electrochemical form of corrosion in which the close proximity of two different metals are in contact, and water containing an electrolyte leads to one of the metals corroding. Okay, which metal will corrode, that depends on the strength with which each metal's atoms are bounded to each other. It depends on material's standard electrode potential, which is the potential difference between a metal electrode and a hydrogen electrode across an electrolyte solution. And a more positive standard electrode potential denotes a material is more active or anodic, and thus is more prone to corrosion. Okay, so it is a form of corrosion in which the close proximity of two different metals are in contact, and water containing an electrolyte, so that you basically it conducts electricity through the presence of ions. Okay, so it leads to one of the metals corroding. Okay, so that is one of the way. So in this technique, a potential difference is not required to be actively applied. It can be a passive form of protection, so we don't need current, basically. Okay, and instead the potential difference is produced by connecting the reinforcement steel to an electrode made from a metal that is more anodic, leading to galvanic corrosion, in which the more anodic electrode corrodes sacrificially and the steel remains largely unaffected. So we can say that in both the impressed current and galvanic cathodic protection, okay, so in both the types, the actual reinforcing bar is made cathode. Okay, and the added item, basically, okay, so the added item is basically made the anode. Okay, the only difference is the impressed current technique uses electricity, whereas the galvanic cathode does not. Okay, so so that is the difference, but other than that, both are made the cathode, so that the corrosion does not occur. Okay, And the absence of an applied electric current does is usually more economical, okay, and when compared with impressed current technique, and therefore it is more feasible. So as you can see here, galvanic cathodic protection, so apart from the current, everything is almost the same, okay. So then let us go to the this one. Let us go to the system, okay. The system of galvanic cathodic protection basically. So it basically consists of strip or mesh type sacrificial anode based on zinc or aluminum or magnesium alloys. So that anode must be in contact with concrete like sheeting attached to the surface, mesh held in place by permanent formwork, thin layers applied using thermal spring or blocks held in shallow cavities in concrete. So the iron, it is uses a iron conductive backfill, which is hydrogel or polymer system, and embeddable reference electrodes. Okay, so this is the system basically. So the chloride extraction. So here basically the electrochemical chloride extraction (ECE) is a technique that reverses the movement of chloride ions into concrete through the application of a potential difference between an electrode at the concrete surface and a reinforcing steel. The configuration is similar to that of impressed current cathodic protection technique, although a temporary external electrode is used and the voltage used is higher, approximately 10 to 40 volt, as compared to the potential differences of a few hundred millivolts for cathodic protection. Okay, so basically the same technique, only the current is much higher. Okay, so from millivolts it is volt. Okay, so that is the difference. And apart from that, we all here also we try to make the rebar as the cathode. Okay, so we are basically changing the poles, okay, for protection. And this is the basically the case. So the this one the presence the principle of electrochemical chloride extraction. So when a potential difference is established between a surface electrode and the reinforcing steel, negative ions migrate towards the anode, okay, which is the case basically generally. And that is always the case basically. Even in OH minus, it goes to the anode, and then FeOH2 is formed, okay, which is rust. So a potential difference is applied between the steel bar and the mesh with a direct current power source. The CaCl2, okay, it is formed, and which can be drained off from the tank also, okay. And this is the working principle of electrolytic chloride extraction. So here it is electrolytic because current is used, okay. Otherwise it would have been electrochemical, okay. So electrolytic solution, CaOH2 tank mesh, and this is the rod, okay. So the chloride or hydroxyl ion ratio is greater than 0.6. Protective passivating layer starts breaking down. Chloride threshold approximately 0.4% chloride by weight of cement. External anode is made of titanium coating, is temporarily attached to the concrete surface, and reactions are driven by a DC power supply. Chloride ions are negatively charged and move from the steel surface towards the external anode. So instead of going to the steel surface, it goes to the anode, which is the titanium coating that is at the surface, okay. That is actually in the concrete surface, okay. So this is the original concrete, and this is the concrete removal technique basically used. So during the electrolysis process, the production of hydroxide ions at the reinforcing steel surface results into a high pH level, indicating a highly alkaline concrete environment after completion of the process, because these hydroxide ions are moving, right? So they are moving outside from the they are separating from the steel reinforcing bar, so it is moving far from that. So basically, it is becoming more highly alkaline. Okay, and this alkaline environment protects the steel against future chances of corrosion, because the corrosion generally occurs in low this one in the low pH environment. Okay, so lesser is the pH, the passivating layer is dissolved, and then the chances of corrosion appear very high. Okay, so that's the beauty. Okay, so if we can increase the pH, there is no chance, like very less chance. And then basically this alkaline environment protects the steel against future chances of corrosion, and this is the free chloride concentrations at different distances from a reinforcement bar with time during ECE. So as you can see here, the 12.5 mm from reinforcement, this is having the maximum free chloride concentration, and as we go far away, it is reducing along with time also. Okay, So that is the benefit. So from here it is going becoming much less. Okay. Then there is realkalization. So this is non-destructive electrochemical treatment to restore the alkalinity of carbonated concrete for prevention of further corrosion of reinforcements. It is usually done on carbonated concrete where pH levels within a structural element have dropped or threatened to drop, causing carbonation. Application of an electric field between the reinforcement and an anode system embedded in an electrolytic source and temporarily placed on the concrete surface. Instead of using a power supply, a sacrificial external electrode, example aluminum alloy, can also be used in the configuration similar to galvanic cathodic protection. Then, what is the principle of realkalization? So it is electrochemical technique that is used to produce hydroxide ions at the reinforcement as occurs during cathodic protection and chloride extraction and cause the migration of alkali metal ions toward the steel to passivate its surface. Here the electrolyte used is normally K2CO3 or Na2CO3, which permeate the concrete and further increase levels of alkalinity in the concrete pore solution. So the electroosmosis and migration of ions take place. Electrolysis at steel surface produces alkaline environment. Okay, so that is the way. Okay, so this is the working principle of realkalization treatment. So as you can see here, so basically this is the reinforcement. Okay, and here as it is told, so it produces hydroxide ions at a reinforcement. Okay, and cause the migration of alkali metal ions toward the steel to passivate its surface. So this will again move ahead. Okay, OH minus will go outside and the Na, this one alkali elements will come inside. Okay, and the electrolyte uses normally K2CO3 or Na2CO3, which permeate the concrete and further increase levels of alkalinity in the concrete pore solution, and electroosmosis migration ions take place. Okay, so as can be explained, so this is a schematic principle representation. So the increase in OH minus at the surface is the result of their production at the reinforcement surface. The increase in Na plus is the result of the migration of ions from within the concrete and from the electrolyte solution used in the treatment. So the evidence for Na2CO3 electrolyte having reached the reinforcement is the relatively small increase in CO3. It results in a relatively increase in CO3 2 minus ion concentration. Okay, so because of high concentration, the carbonate concentration will also increase, and as you can see here, so basically OH minus and the change in the concentration of OH minus, Na plus and CO3 2 minus basically at the reinforcement undergoing realkalization. Okay, so as you can see here, the concentration of sodium ion will increase the maximum. Okay, so that will increase and this will also increase, but this will move. Okay, OH minus will move, go away, and carbonate will be minimum. Okay, so there is no issue of any carbonation happening basically. So then after treatment, the pH is considerably higher, mostly due to the production of OH minus. The pH around the reinforcement may typically decrease with time due to the diffusion of ions caused by the differences in concentrations of ions at different locations in the concrete. Generally, it stabilizes at a pH of 10.5, which is adequate for passivation. So, any pH, like any depassivation always occurs less than 10. Okay, 10 is the threshold value. Generally, 10 or 9. For carbonation, it is 9. So basically we consider 10. Okay, 10 is a standard value. So if it is 10.5, then it is not an issue. Okay, so this is the profile of pH and sodium concentrations in an untreated carbonated specimen and a realkalized specimen after treatment for 33 days. Okay, then let us study the corrosion inhibiting admixtures. So here agents, these are agents that increase the chloride threshold level, which causes depassivation and also slows down the corrosion once depassivation has occurred. So here the corrosion inhibitors can be inorganic and organic compounds. The inorganic corrosion inhibitors like calcium nitrite, CaNO22, sodium nitrite, sodium molybdate, sodium fluorophosphate. Okay, so these are the inorganic corrosion inhibitors. And then there is organic corrosion inhibitors like malonic acid, disodium glycerophosphate, amine compounds, etc. So they act as anodic or cathodic inhibitors. So these anodic inhibitors, which are basically inorganic compounds, so they basically oxidize FeOH2 into FeOH3, so ferric hydroxide, and they remove nitride ions and thus lowering the Cl minus by NO2 minus ratio. The cathodic inhibitors These are basically the organic compounds. They form a protective layer at the steel surface, thus limiting the chloride and oxygen to reach the reinforcement. Okay. So the reinforcement coatings are basically of two types. One is impermeable material and one is sacrificial coating. So the impermeable coating, it uses application of epoxy resin, and the sacrificial coating, they are galvanized treatment coating the surface of steel with a thin layer of zinc, which is approximately 10 to 250 micrometer thickness. Then we can also so let us see the epoxy coating. Okay, so they are basically isolate steel. They basically isolate steel from contact with oxygen, moisture and chloride, thus preventing corrosion of steel reinforcement. So we basically commonly say it is very popular, epoxy. So this is it isolates contact with oxygen, moisture and chloride, thus preventing corrosion of steel reinforcement. And the thickness of epoxy coating is around 0.3 millimeter. Okay, so as you can see here, the epoxy coating of existing reinforcement, it is done. So the sacrificial coating galvanized treatment, so here zinc being more anodic than steel, it undergoes corrosion and still remains uncorroded. Under conditions of relatively low chloride concentration and pH level typical of concrete, zinc is passivated and thus acts also as a physical barrier to the reinforcement against chlorides. Chloride concentration required to depassivation of zinc is much higher. The corrosion products of zinc being non-expansive, so cracking is reduced and thus further production of steel. So that is the sacrificial coating or galvanized treatment. So this is the example of epoxy coated steel bars, and this is the example of galvanized reinforcing steel. Okay. So if we summarize this lecture, we basically understood the corrosion treatments of steel reinforcements through cathodic protection, chloride extraction, realkalization, corrosion inhibiting admixtures, and reinforcement coatings. Okay. So the next lecture will be on strengthening of structural components. So here we'll basically be covering conventional strengthening techniques, attachment of steel to concrete and crack stabilization, strengthening of structural components, advantages and limitations of strengthening with steel. Okay, so these are the concepts we will be covering. Strengthening is basically upgrading the capacity of a structure over its original design. The strengthening of structural concrete can be done by replacing poor quality or defective material by better quality material, attaching additional load-bearing materials, and redistribution of the loading actions on the structural system. So these are the ways, okay, of strengthening. One is replacing, one is attaching, and one is redistribution of the load action. So uh, basically, the new load bearing material, so there can be of high quality concrete reinforcing steel bars which can be longitudinal, lateral or stirrups, etc. So stirrups are basically the shear reinforcements in beam. Okay, and thin steel plates can be used, straps, tendons, etc. Fiber reinforced polymer composites which can be sheets, plates, bars, etc. and various combinations of this. Okay, so these are new load bearing materials. And then the techniques, okay, so one is a section enlargement. Okay, so new additional concrete and reinforcement steel is done, it is added and bonded to existing concrete to act monolithically. Okay, so it is done as if it is made such that the whole beam, the new beam is similar to the original beam, the properties are the same. Okay, and it is like homogeneous. Okay, and then the composite construction, so it is placement of additional plates, structural shapes of steel or other materials to increase the stiffness or load. Okay, carrying capacity. So it is a placement of additional plates, structural shapes of steel or other material to increase the stiffness of or load carrying capacity and the load transfer in the composite material by the use of adhesives, grounds, mechanical anchors, etc. Okay, so that is composite construction. And then there is post tensioning. This is placement of tension components either internally within the member or externally to the member by jacking. And the tension components can be steel plates, rods, tendons, strands, etc. It provides the member an active load carrying capability, relieves overstressing, reducing deflections, etc. And the stress reduction, so it is by cutting new expansion joints, jacking, display structure, installing isolation bearings, removal of portions of structure, etc. And it reduces stress in a member or structure. So this is the basically this is how it is achieved. Okay, And then let us one more way can be the internal grouting. So this is pressure injection of flowable materials into cracks, voids, discontinuities to regain the structural properties and strength. The materials for grouting can be polymers, cement based materials, etc. And the external grouting similarly can be pump materials outside the structure. So this is inside and external is outside. So it is pump materials outside the structure to fill voids between the structure and the surrounding soil, to provide necessary load transfer between the structure and soil, or to displace unwanted settlement. Materials for grouting, so it can be cement based materials, chemicals, etc. Okay, so now let us see the attachment of steel to concrete. So steel is utilized to strengthen connections or to provide additional tensile capacity. So the attachment is done by mechanical connections, adhesives, as well as combinations. The attachments permitting load transfer, that is shear, tension, or compression between the steel and the concrete. So there are different techniques of attachment of steel to concrete, as you can see here, through expansion anchor, resin bonded anchor, epoxy adhesive, resin bonded anchor, and epoxy adhesive combination. And then there is this one, through bolting. Okay, so these are the techniques of attachment of steel to concrete. Okay? So now let us see crack stabilization. Okay, so so this is an example of improper crack treatment. So if adhesive is placed into crack when the crack is small, okay, so then the glued member, okay, may not resist the stress developed, okay, when the member contracts, okay, thereby causing tensile failure. So it will not be able to resist the contraction when the temperature is less. Okay, so then what happens is it will result in tensile failure, okay, because it will generate tensile stresses. However, what is the proper crack treatment? So when the crack is open, okay, and the adhesive is placed in crack, so if the adhesive is placed into compression, okay, when member expands, so then the balance is achieved. Okay, so if it is in compression when the member tries to expand, so then the crack treatment is proper. So that is done through application of compressive forces which are transmitted to restraints. Okay, so when the tension force is there, so if we when the tension it tries to expand, if we provide extra compression forces, then it is balanced. Okay, so there is no crack. Okay, due to the change in temperature. Okay, then the next case is your strengthening of structural components. Okay, so the components can be beams, girders, slabs, and columns. Okay, so for beams and girders, so girder is basically a beam with very high I, okay, moment of inertia. For beams and girders, the strengthening can be done through shear and flexural strengthening, because they basically take shear and flexure, which is bending. For slabs, it is basically flexure, okay, or no shear, because it is a very wide shape. Okay, so there is less chances of shear, more of flexure. Okay, and columns it is basically axial and confinement strengthening. Okay, so axial is the axial through the axis, and confinement because it is always confined columns. Okay, so loads are distributed from the top. Okay, so let us first see beam shear strengthening. So the techniques for increasing beam shear capacity are internal post tensioning, external post tensioning, internal steel reinforcement, external steel reinforcement, and section enlargement. So these are the techniques for increasing beam shear capacity. The internal and external post tensioning. So here this is the internal post tensioning. So as you can see here, the drill hole through the member, inside the member the hole is drilled, and this is the example of external post tensioning. So here the member, the drilling is not done throughout the whole member. Okay, so it is outside the member. So small amount of drilling is done, but it is not through the body, not through the axis of the member. Okay, so this is the example of internal post, and this is external post tensioning. Okay, so in external post tensioning, so this is if you see, this is the shear crack which are diagonal, and the shear crack epoxy grouted before post tensioning. Okay, and post tensioning rods on each side of beam. Okay, so these are the post tensioning rods developed on given provided in on each side of the beam. And then there is this internal steel reinforcement. So here if we see, there is addition of internal steel reinforcement. So this is the girder, these are the existing stirrups, there are shear cracks, and we have diagonal drilled holes and provided them. Okay. So similarly, these are the external steel reinforcement. Okay, these are the shear cracks, and here how it is external steel stirrups are provided. So they are provided outside. Okay, the reinforcements. As you can see in the steel plate bonding example. So this is the addition of external steel reinforcement. So the techniques for increasing beam and slab flexural capacity. So there are various types. One is concrete encasement or section enlargement. One can be concrete overlays. One can be externally bonded steel plate. One is external post tensioning. One is near surface mounting. One is span length shortening. And one is supplemental support. So these are the ways or techniques for increasing beam and slab flexural capacity. So these are the examples of concrete encasement and overlay. So as you can see, this is the existing beam, okay, the dark shape, and we have added extra, okay. So this is the beam encasement and this is the overlay. So overlaying from top side and soffit is from the downside, and using suitable formwork, shotcreting, increase in dead load, okay. So concrete overlays and encasement. So this is the beam encasement on section enlargement, as can be seen in the schematic diagram. That is for beam and slab flexure strengthening. Then there is concrete overlay at top and bottom of slab. Okay, so if you can see here, so here it is concrete overlay from top, and here it is concrete overlay from bottom. Okay, so this is of slab. Okay, so overlay on top of slab, overlay on bottom of slab. Then there is externally bonded steel plate. As you can see here, it is externally bonded, and above that it is this new overlay is provided. So plate bonded at top and bottom, as you can see, and we have this one strengthen the members using external and internal this one reinforcements. Basically external and internal reinforcements have been provided. Okay, so after that, so if we see, this is the example of correction of deflected member with bonded steel plate. So this is deflected slab. Okay, so lifting of deflected slab has been done through bonded steel plate and installation of the steel plate. Okay, so this is the example of how correction of deflected member using bonded steel plate. Okay, so this is again, this is example of steel plates at the tension faces of the beam. Okay, so we have added steel plates at the tensions faces of the beam. So this is the way. Okay, then beam and slab flexure strengthening. So external post tensioning. So high strength steel strands are used to increase the strength of damaged concrete structures. The tendons are pulled and connected to anchor points. Anchoring by shear transfer mechanism or by end bearing assembly with side mounted or soffit mounted and bolted. And high fatigue and impact resistance is provided. Okay, so that is external post tensioning. Then there is, so this is the example of external post tensioning and tensioning of external PT post tensioning tendons, as you can see here. So this is the example of externally post tension concrete beams. So this is the reaction frame and this is the beam. These are the end anchorages. This is column. So externally mounted post tension strain on each side of beam. So external post tensioning, it has difficulty in providing anchorage and post tensioning strengths. It has difficulty in providing lateral stability, and there are corrosion of steel strengths. So these are the characteristics. And then there is near surface mounting, NSM. So NSM steel bars in concrete beam. So addition of tensile reinforcements perpendicular to the plane of the crack. Okay, and a shallow groove or slot is a saw cut across the crack larger than diameter of bar and is cleaned. Insertion of cementitious grout or epoxy resin into the clean slot as a bonding agent. Steel bars are placed in the slot and the surface is leveled. Okay, so these are the ways of near surface mounting. Then there is span length shortening. So as you can see here, this was the original span length and this reduced into the new span length by providing new knee braces or a new steel framing. Okay, so that is how the span length shortening can be done. Then there is supplemental support. Okay, so we are adding additional support, okay, to help to support to basically aid, okay, so assist the structure. So this is the example of supplemental support being provided, as can be seen here. Okay, this section. Okay. Then there is wall strengthening. Okay, so here as you can see, strengthening of retaining wall by section enlargement. So this is new concrete retaining wall cast next to the existing retaining wall, okay, for support. Then there is wall, as you can see here, there is wall buckle from excessive soil pressure strengthened by using additional steel frames. So these are the frames, okay, to support the excessive soil pressure. So the strengthening of columns. So there is increase in axial capacity, increase in ductility, increase in shear capacity connection, and increase in moment capacity connection. So this increase in axial capacity can be through section enlargement with additional reinforcement. Increase in ductility can be through additional stirrups, concrete jacketing, steel jacketing, etc. Increase in shear capacity connection can be through additional of shear collars. Then the this one increase in moment capacity connection can be through addition of steel plates, shear walls, etc. Okay, so that is the strengthening of columns. So as you can see here, so this is the section enlargement. So this is the existing section, so we have added new. This is the method A for column. The method B is basically using like tying the this one the tie bars. So the shear reinforcements are basically called tie bars in columns. So if the tie bars go through both the existing as well as new sections, okay, so then it is this is the second method. And then there is the third method, which where we are just tying it tying it outside the existing section, okay, so only tying in the new section. So that is also method. And in the method A also, so you can see after column enlargement, there is dry pack space between column and member after adequate drying shrinkage has occurred. So this cases also emerge. So this is the practical example of how to do the strengthening of columns as per CPWD handbook. And this is basically the RCC jacketing done, okay. So how the jacketing is done of the column, okay, as has been shown here, taken from CPWD handbook. So the steel jacketing, lateral confinement of concrete columns using steel jackets or straps laid intermittently along the height of the column, as has been shown here. And the shear capacity strengthening using shear collars are also shown. So shear collar steel or concrete, the non-shrink grout to be applied after erection for uniform load transfer. So this is the shear collars, okay. So this collar basically they can take the higher amount of shear, okay, and distribute it appropriately into the column. So here it is the example of beam column moment capacity strengthening using steel plates, concrete shear walls, etc. Okay, as can be seen. And then what are the advantages of strengthening with steel? So it is compatible material with high strength. It does not need no need of closing the operation of the structure. Practically no change in the original dimension of beams and columns. Easy mechanism for placing and erection at site. Okay, so these are the advantages of strengthening with steel. What are the limitations of that strengthening with steel? So steel is susceptible to environmental attack. So chances of corrosion with natural exposure to environment. Difficulty in handling and cutting of steel plates at the site due to heavy weight. Difficulty in splicing of steel plates and formation of joints due to limited delivery length of steel plates. Difficulty of field welding due to heavy weight. So these are the limitations of strengthening with steel. So apart from that, need for a larger than structurally necessary jacket thickness to ensure that steels do not buckle with while lifting into places. Steel being isotropic and having a high stiffness is not the best material for use in concrete confinement, since a large portion of the axial load is taken by the steel tube than that of concrete. The efficiency of confinement is reduced through separation. Failure of the epoxy at the epoxy concrete interface. So these are some of the limitations of strengthening with steel. So if we see the summarize the lecture. So we have studied about conventional strengthening techniques, attachment of steel to concrete and crack stabilization, strengthening of structural components such as beam shear strengthening, beam and slab flexure strengthening, wall strengthening, and column strengthening, advantages and limitations of strengthening with steel. So these were studied. So now let us go to the next lecture, which is strengthening of structural components. Sorry. So we'll be basically studying about the strengthening of foundation and slab jacking. So strengthening of foundation can be done through two ways. One is section enlargement of footing, and second is underpinning. So This is the section enlargement with reinforcements, as you can see here. And this is the strengthening of footing, okay, with both the design, okay, the plan and the actual site, okay, strengthening done. So the strengthening of footing can be drilled hole through member, insertion of dowel bars. So they basically join the two or more foundations and slabs, or distribute the loads, okay. Arrangement of reinforcement like casing, concreting in extended portion, okay. So these are the strengthening of footing type, as the strengthening ways of footing. So secondly, there is underpinning. So that is method of supporting the structure while carrying out repairs and alterations, or providing a new or additional foundation without disturbing the stability of existing structures. Okay, or and process of modifying an existing foundation by providing an extra support. Okay, so this providing an extra support uh, as in the foundation is basically underpinning. Okay, so need for underpinning is to strengthen a shallow footing when a structure with deep foundation is to be constructed adjacent to the shallow footing, to protect an existing structure from the danger of excessive or differential settlement, to improve the bearing capacity of foundation area, and to provide a basement or additional load for an existing structure. Okay, so these are the need for underpinning. Okay, so the steps before underpinning is proper evaluation of the existing structure, necessary repair including grouting, crack sealing, and adequate shoring before underpinning. And the methods of underpinning are pit method, pile method, chemical method, and other method like cement grouting, vibro flotation, etc. So these are the methods and steps for underpinning before and after. And then there is deepening and enlarging existing foundation by removing soil from beneath the foundation and replacing it with concrete or reinforced concrete and grout material. It needs proper shoring or to prevent settlement. Often results into moderate deformation of structure and simple and low cost method. Okay, so that is basically the pit method. Okay, so this is the underpinning by pit method, if you can see, and this is the pit method of underpinning with cantilever nail. Okay, so as you can see here. So now, second is the pile method. So this underpinning done by pile method. So this is strengthening existing foundation by installing piles through pre-drilled holes, high load carrying capacity, low settlement, low noise and vibration. Underpinning piles, micro piles, jack piles. So this is underpinning by pile method. And then this underpinning piles normally provided in pairs, one on each side of load bearing wall, or in groups around the sides of columns. Micro piles, they are small diameter piles, high strength with steel casing, installed from ground surface by rotary drilling. Uh, there are jack piles, they are precast piles. Underlying ground is preloaded before the load of the structure is finally transferred by means of jacking between the tilted existing structure and the new underpinning. So these are the jack piles. Okay. So this is a typical section of underpinning bay, as you can see here, and this is the elevation of underpinning bay. And then this basically it is jack pile underpinning. So it is done. Jack pile underpinning, it is done where the traditional underpinning is uneconomical because of the depth of suitable bearing capacity of subsoil. Advantage is it is vibration free and flexible because the pile depth can be adjusted to suitable subsoil conditions encountered. So this is the typical section of jack pile underpinning. So then there is needle and pile underpinning. So it is used where the traditional or jack pile underpinning techniques are unsuitable for the existing foundation condition. So then there is a pinford stool method of underpinning. So that basically, if you see the pinford stool method for underpinning, so it has various stages. Okay, one up to 6 stages. So first stage here, the holes formed in wall to receive steel or precast concrete stools. Then there is second stage where stools inserted and pinned to a soffit of brickwork over opening. Then third stage, brickwork between pin stools removed to leave wall supported on pin stools. So used when the existing foundation soil has poor bearing capacity. So that is the third step. Fourth step is reinforcement fabricated in place around pin stools. Fifth stage, formwork erected and beam cast. 6 stage formwork removed, beam allowed to cure before being pinned to underside of wall. Okay, so these are the stages. Okay, so then there is root pile or angle piling. So root pile or angle piling method of underpinning, as can be seen here. Then there is this if you can see it shows the typical details of underpinning columns. Okay, and then underpinning column with cantelage load. Okay, so these are some of the loads, okay, which are called cantelage loads. Okay, so it is of precast concrete blocks or similar to act as counterweight. Okay, so then there is underpinning by chemical method. So foundation soil is consolidated by employing chemicals. So perforated pipes are driven in an inclined way beneath the foundation to cover the entire area of footing. After installation of pipe, sodium silicate mixed with water is inserted through pipes, and then the pipes are withdrawn. Chemical reaction takes place between the chemicals, and the soil is strengthened by consolidation. So then let us come to slab jacking. Okay, so it is the process of raising slab on grade or filling the voids underneath, or both, by injecting a cementitious or non-cementitious or asphaltic grouting material under pressure. So it is used to level and align concrete slabs on grade that have shifted, moved, misaligned due to settlement, erosion, flooding, or shrinkage of soil base layer below the slab. So this is the slab jacking in progress before and after, as you can see. So prior to slab jacking, soil conditions need to be determined. Holes are to be drilled in staggered pattern, 1.5 to 3.0 meter center to center for inserting the grouting materials. If the soil is tight below the slab, a void may be created to start slab jacking. This will distribute the pressure of the grout over a large area, resulting in more control and an increase in lifting area. Grout pressure need to be monitored by pressure gauges mounted near the pump discharge and also near the grout discharge nozzle. After completion, the grout holes need to be finished with a repair mortar to level the surface. Resurfacing the slab can be done with a polymer modified cementitious material for more uniform appearance. So this is a typical layout of slab jacking holes, and these are the void created below the slab to initiate slab jacking. This is pumping of grout in drilled hole indicating soil grout flow, and this is a typical cracking pattern in a slab. So these are the benefits of slab jacking. It can be done on any weather. Material injected below the slab provides a strong base, little or no change in landscaping, and it is not expensive. And the possible problems of slab jacking are additional weight of slab jacking grout may cause further soil settlement. If the soil settlement has not terminated, the jacket slab will continue to settle. Consequently, subsurface erosion and continuous shrinking of supporting soil may also result. Okay. Then there is cracked and sinking driveway restored by slab jacking. So this is before and this is after. And there is sinking walkway raised and leveled by slab jacking before after, as you can see here. So based on this lecture, so we have basically studied the strengthening of structural components, the strengthening of foundation, section enlargement of footing, underpinning, and slab jacking. Okay. So now let us come to the solve problems and understand more the lectures in a more detailed manner. Okay, understand it properly. So the first question is the types of shoring that is provided as restraint against tilting overturning are A, raking shores, B, flying shores, C, dead shores, or D, all of the above. What are those? Okay, which the shoring types which provide restraint against tilting overturning. So if you remember, so the raking or inclined shores, so there the angle of shores are 60 degree to 75 degree for external supports. So they are not for tilting overturning. So A is not correct. Then dead or vertical shores, they are provided on ground supporting vertical loads. Okay, so not against tilting overturning. So C is also not correct. Then flying or horizontal shores, they restrain, they provide restraint against tilting overturning. So this B, flying shores is they provide against tilting overturning. So B is correct. Okay, so B, flying shores is the correct option. Second question, select the partial depth concrete removal method or methods. A, hydro demolition, B, pneumatic or hydraulic mounted breakers, C, rotary milling machine, or D, all of the above. Okay, so if you remember, this rotary milling machine is there, so it is yeah, so it is correct. Okay, if you say hydro demolition, so there is no method as such, it is hydro removal. Okay, so that is A is not correct. And then there is this is pneumatic scabler, but here it is pneumatic or hydraulic mounted breaker, so that is also the not correct one. Okay, so for partial depth removal, so the correct is C, rotary milling machine. So C, rotary milling machine is the correct one. Third question, which of the following grouting method is not used to fill underground voids? A, cement grouting, B, epoxy injection grouting, C, chemical grouting, or D, none of the above. Okay, so if you remember epoxy injection grouting, okay, so they are basically uh, used for small channel. Okay, so epoxy resin in a low viscosity liquid hardener is injected into cracks with pressure to fill up the voids and cracks. For it is useful for repair of small crack as narrow as 0.005 mm. So it is not for underground void. Okay, underground is for cement grouting and chemical grouting. So B, epoxy injection grouting is the correct option. So as you can see, B, epoxy injection grouting is the correct option. Fourth question, statement 1, dry pack and epoxy bonded dry pack is immediately packed and placed in thin layers 8 to 10 mm and compacted with hammer. Statement 2, dry pack and epoxy bonded dry pack is suitable for small areas. So out of this, what is correct? 1 is correct, 2 is correct, both are correct, or none of them are correct. Okay, if you see here, uh, so dry pack and epoxy bonded dry pack, so they are immediately packed and placed in thin layers. Okay, immediately packed and placed in thin layers 8 to 10 mm and compacted with hammer. Okay, so one is correct. Okay, so this one either D is incorrect and B is also incorrect. So either A or C will be correct. Out of A or C, one will be correct. So if you see dry pack and epoxy bonded dry pack is suitable for small areas, so it is also true. Okay, dry pack and epoxy bonded dry pack suitable for small area. So both are correct. Okay, so C, both the statements are correct is the right option. So as you can see, C, both the statements are correct is the right option. Fifth question, statement 1, pre-placed aggregate concrete are generally suitable in areas of heavy reinforcements. Statement 2, in case of pre-placed aggregate concrete, grouting starts from the top of pre-packed aggregates. Okay, so 1 is correct, 2 is correct, both are correct, or none of them is correct, which is true. Okay, so if you remember, one is true, pre-placed aggregate concrete are generally suitable in areas of heavy reinforcements or where the placement is different. Okay, so difficult, so one is correct. And in case of pre-placed aggregate concrete, grouting starts from the top of the off press, so this is incorrect. Okay, it always starts from the bottom. Okay, so 2 is incorrect, so only one is correct, that is A. Okay, as you can say, A, only statement 1 is correct is the right option. Sixth question, choose correct option regarding ferrocement. A, fire resistant, permeable, low cost. B, high strength. C, low durability. D, all of the above. So if you see here, ferrocement is fire resistant, impermeable, low cost. For fire resistant, impermeable, low cost, not permeable. So A is incorrect and therefore D is also not correct. Okay, so out of B and C, and it is low strength, so high it is not high strength, so B is also incorrect. So what is correct? C, low durability. Okay, C, low durability is the correct option. So C, low durability is the correct option. Then seventh question, this is a picture of what? Crack. So this is a picture of what? Stitching, stapling, both, or none of them. So if you remember, this is a these are staples provided. Okay, so it is an example of stapling. Stitching occurs when we are inserting a rod from one side and it is going down and inclined, and it has crossed the crack, and when it has gone to the next side. Okay, so that is stitching. So here it is, example is stapling. So B, stapling is the correct option. Question, in case of galvanic cathodic protection, a potential difference is not required to be actively applied. B, the potential difference is produced by connecting the reinforcing steel to an electrode made from a metal that is more anodic. C, the more anodic electrode corrodes sacrificially and the steel remains largely unaffected. D, all of the above, which is correct. So this is true in galvanic cathodic protection. It is potential difference is not required to be actively applied. So that is actively applied is for impressed current. Okay, so it is galvanic cathodic protection is not actively applied, so it is correct. The potential difference is produced by connecting the reinforcing steel to an electrode made from a metal that is more anodic. Okay, so that is also correct. Okay, so B is also correct. And more anodic electrode corrodes sacrificially and the steel remains largely unaffected. So that is also correct because the corrosion mainly occurs near the anode. Okay, so A, B, C all are correct. So D, all of the above are correct. Okay, so D, all of the above is the right option. So D, all of the above is the correct option. Ninth question, in case of chloride extraction process, statement 1, a potential difference is applied between the steel bar and the mesh with a direct current power source. Statement 2, during the electrolysis process, the production of hydroxyl ions at the reinforcing steel surface results into a low pH level. So A, only statement 1 is correct, B, only statement 2 is correct, C, both of these statements are correct, or D, none of these statements is correct, which is the right option. Okay. So if you remember, a potential difference is applied between the steel bar and the mesh, okay, with a direct current power source. Okay, so that is true. Okay, in chloride extraction process, we provide a potential difference which is applied between the steel bar and the mesh with a direct current power source. However, during the electrolysis process, the production of hydroxyl ions at a reinforcing steel surface, it results in a high pH level because the hydroxides goes into the anode side, and the alkaline elements come to the cathode side, which is the reinforcing steel which is basically the reinforcing steel. Okay, so that results in high pH level. So statement 2 is not correct. Okay, only one is correct, that is A is the correct option. Okay, so A, only statement 1 is correct. And the 10th question, identify the correct statements regarding slab jacking. A, prior to slab jacking, soil conditions need to be determined. B, can be done on monsoon weather. C, very expensive procedure. Or D, all of the above, which is the correct option. So if you remember, slab jacking, so it can be done on all weather. Okay, so B is incorrect. It is not very expensive. Okay, it is cheaper. Okay, so C is also incorrect. And prior to slab jacking, soil conditions need to be determined. So that is true. So A is correct. Okay. So A is the right option. Okay. So soil conditions need to be determined. So A, prior to slab jacking, soil conditions need to be determined is the correct option. So with this, we come to the end of today's discussion. So we basically try to understand the various types of methods which can be used for retrofitting and repairing concrete structures, and also we try to expand our knowledge through solving a few solved problems. Okay. So with this, I would like to end today's discussion. Let us meet next week again and start and let us discuss the fourth week lecture as well as problems. Okay. So with this, I would like to end today's discussion. Thank you.